right, so what happens a week from today? Exam. So exciting. Mark, how easy are my exams?
There are a lot of writing. They're not easy. Get ready. You gotta be ready.
Gotta be ready.
If you're
But
not ready, they're hard.
if you're ready,
They're hard.
you're just tired of writing. Right? All right. So, the basic gist of it is anything I covered in class, anything I think I've covered in class, anything I covered in one of the other classes, but I thought I covered in here, right? I can put on there. Right? So Mark, was there anything on any of the exams you took for me that we actually didn't cover?
No.
So if you've paid attention.
Actually, there was one question you gave us credit for because you.
Oh, that's right, there was. Yeah, I got confused as to that, and I actually give them all credit for it because it was something we didn't cover. But you guys did a great job, like, faking it, so. All right, so in general, it was going to be short answer. The numbered questions really don't correspond to the actual number of questions. Would you say it's an accurate description, Mark?
Say that one more time, sir.
Like, I have them numbered like 1 through 35, but there's actually like 100 questions.
Yeah.
Yeah.
Read the whole question.
Yeah. Yeah. So I will tell you up front, right? The majority of time that I take off points is because people don't answer all parts of the question. And will I ever give out full credit if you leave a part out? No. So make sure when you go to turn it in that you have answered all parts to the questions. Simple as that. Okay, so it is, I'm not looking for you to memorize anything. Right, so don't think you have to memorize the wording on these slides, doesn't matter. The wording that I said specifically in class, I don't care about, right? As long as you, right, your job on this exam is to show me you understand the material. And actually, I prefer it if you are able to describe it in your own terms, because that means you understand it, right? Memorizing something for an exam doesn't mean you know it. I want to know that you understand it. So don't try and memorize it, but it needs to be the right definition. Right? Right? So what'd you think of my exam, sir? Hard, really hard, super hard.
But I got a really good grade, but still.
I mean, so think about it. Like, they still took it even though they already had me and took exams.
But will you give us like a review today?
A review? A review of what?
Please.
No, what do you want a review of?
Review about the exam.
Anything we talked about? Okay, so think about all the things that we have talked about up to this point. What is kind of if we go back to day number 1, what would be a great test question to ask you about on day 1? What is the first word in this course? Data. So do you think you're going to have to identify or give me a definition of what data is?
Not information.
It's not information. You are correct. And if you give me that as the definition for data, I will smile. I go, great job. I might even draw a little smiley face on your thing, but that'll be a big 0. Right? 'Cause even though that's a true statement, you have to, right? So, and I didn't even pay Cooper for this, right? So, but this is the exact thing I am looking for, right? Answer the question that I am asking you. Not, oh, it's not this. Well, it's great that it's not that, but what is it? Right? So, and I'm still not going to pay you for anything. So. All right. So, what is data? It's a fact, right? And what is information, since Cooper brought it up? It's not a data.
Has
Right.
context.
Yeah, you're putting this fact or this piece of data in context. Right? That's what we're trying to do. Okay? Right? So after we work our way through what data is, we need to capture that data somehow. And how do we capture it? In some sort of database. So therefore, you should be able to describe to me what a database is. So what's a database? It's a collection of data. Okay, well that's nice, but I'm not going to give you full credit for just it's a collection of data. Right? Because what way do we have to look at a database? It represents data about a particular environment, a particular system, a particular set of things, right? Okay, so our database is, yes, it is truly a collection of data, but we are logically grouping that data together, right? We don't, right, I'm assuming, because I've never seen one, that there is no company out there, right, that has one single database that represents everything in the entire organization. Right? We logically group them because we need to make it efficient. So if I was to ask you about what are the trade-offs that we have in the database world, what are you going to tell me? God, what a great... Mark, you should be writing these down because, you know, when I go to make up the exam, I'm never going to remember any of these. Too late.
How could I sabotage that?
Right? So what are the trade-offs?
In terms of using a database versus not using a database?
That would be one aspect. Right? So in the database world, we have database management systems that describe to us and give us a set of tools to create, access, update, right, the data to match what we need to do, right? And the trade-off associated with that is somebody's got to pay for it. Somebody has to build something around it, right? We can't just magically snap our fingers and there's magically a database system with all the databases defined and, right, we can access it and update it, right? We have to build processes around this, right? So the trade-off is also efficiency, right? So if we talk about performance, because what is the amount of data that we have? The more data you have, the longer it's going to take to process against it, and how much time do you actually have to deal with that? Okay. So what other kinds of things did we talk about? What's in the database management system? What's the order that we process things against, right? So, right. So let's go back because you guys don't want me to do this because you'll try to hold me to everything. So we'll do that. Right. Okay, so we had different types of databases. You should be able to describe the different types of databases that we have. So what we have application domain, so this is the type of data that we have, and then the database management systems that we have associated with that, right? So we had all of these. So again, I'm not asking you to memorize these, but if I say any of these things, you should be able to describe in your own words what they are. Okay. Okay, so when we talk about what's this whole mini world thing without looking at this? It's the environment or the domain of what you are looking for, right? That you're going to ultimately model. Because what does databases do? They model something, and what do they model it in terms of? Data. Okay? So we're modeling our world, and it's called a mini world because we can't model everything. We're modeling our piece of the world in a way that we're going to understand what all the data is and how the data interacts. And we're going to use this wonderful database management system to access and keep track of all of this data so that we can perform actions against that data to understand the data, make decisions using that data, run the organization, whatever it happens to be associated with that. Okay, right? So so a key thing to kind of think about is looking at these pictures, right? So we just, right? So given a picture, be able to describe it, or if I say, here's what it is, be able to kind of draw out or at least describe what the pictures are. So what about this one? Who can tell me about this? We have down at the bottom, we have the data and the definition of what that data looks like. In the middle, we have the database management system, which is actually going to manage or control the access to the data, the updating of that data, stuff like that. And to get to the database management system, you need something up front, whether it's a person, an application, something like that, that is going to direct the database management system to say, here's what I want you to do. Okay? So up front, it's someone is directing through some mechanism, right? A direct command, an application, whatever it is. Here's the action database management system I want you to do, so go do it. And it's going to go off and do it, and to do it, it has to physically access the metadata, so you should be able to describe to me what a metadata is, right? And using the metadata, it's going to go to the database and do the action that you are describing, and it's going to return the result back to the end user in some way, shape, or form, right? So you should be able to describe it top to bottom, and then bottom back up. Okay. So, okay. All right. So again, it was just examples that they have in here, so it's nothing. Okay, so in this one we had some of the approaches. So what was so we went through this kind of list here, right? What's a concurrency control? A large organization is going to want to have concurrent access or concurrent actions against a set of data. So the database management system ultimately has to be able to handle all these concurrent things, right? So if you think about your online transaction processing for a company that is taking orders, right, online, right, you don't funnel it through that only one person can place an order at a time, right? So we have to size the database management system actions according to what the volume is going to be. So if I have a online store, what day am I looking for in terms of the maximum usage of the data or access to that data? Because it's coming up, right?
Black Friday or Cyber Monday.
Right, one of those two is going to be really big, right? And what have they tried to do? Spread all that out to even more days, right? Right? Because they want to spread the access, right? Because what happens when you have too much access going on at the same time? It's going to lock people out, slow it down. And what happens to a consumer that can't get through, you go somewhere else, right? You're not willing to stick around, right? So it's got to be fast, so we need to be able to do that, right? We also talked about the recovery process, right? So it's recovery or the integrity of the data as well as the entire database, right? Okay, so Cooper, I think it was you that we talked about in terms of you and hitting the ATM machine, right? So what was that all about?
What exists logically and what exists physically?
No, that was a different one.
With an ATM machine.
Okay. Okay. So that was we wanted to do all of the actions or none of the actions. Right? If you go to the ATM machine and you put in the card and you say you want $200 out and the machine can't give you the $200, but it's already deducted the money out of your account, you want it to put the money back in before you leave. Right? So it's all or nothing, right? So the concept of that is about having a, what we call a unit of work. I have to complete all of the unit or none of it, right? We talked about it in terms of processing orders that come in. I want to group all of the orders, right? So we talked about online versus batch processes, right? Why do we do batch processes? To make it more efficient, right? We talked about that in terms of the banks, right? You see pending all day and then overnight they apply all of the stuff so that we make sure that all of the incoming amounts are applied before any of the outgoing, because customers are going to get mad if you deduct things and give them a fee when they put money in and you just didn't put it in the right sequence, right? So they reorder them at night in a batch process, so they don't allow you to access while it's going on, right? You get the little maintenance screen, right? But the idea is they process it, then they open it back up after they apply it, and everything is pending till the next day that they run, right? So things like that that we're ultimately dealing with, right? All right. And other kinds of stuff what I think to put in here. Oh, backup and recovery, so that's always a good one to talk about. Let's go to the next one. Okay, so data models, right? So what do we have for a data model? That's our ERD, right? So entities, the things. So that was Cooper making the trip, asking to see for his account, right? Okay. Right. Okay. So we talked about schemas versus instances, right? So what's a schema? It's our logical representation of what the database is going to look like. Instances are the physical data values that are going to result in us having an instance of data inside that domain. And what was our domain of values? Right? So our representation of that is if I have a student database, the domain of students is anybody who's in the database. If I try to look up in the database and it's not there, they were not a student, right? If I find them, they are a student, right? So it's giving us the complete set of values, right? Okay, what's the state, right? The key thing about a state was it's a point in time, right? Okay, so I have a set of data in the attributes in the database. If I change it, I'm changing the behavior is the state that I'm in. If I change the behavior, it means I'm changing a value, so I'm changing the state, right, in that process. Okay. Okay, what other kinds of stuff to be talked about. Oh, the 3 schema architecture. Oh, yeah, that sounds great. Okay, so external, so that's what the end users see. The conceptual level is what we think it looks like. And then the internal is how it's physically stored, right? So it's, you have a external view, what the user sees it as. They don't really understand databases. They don't understand the way that it's laid out, right? They just know that if I do these kinds of things, I get access to this data, right? Okay, at the conceptual level, somebody had to say this is what it logically looks like, and then somebody had to ultimately figure out what it's actually physically going to look like, right? So we have the 3 layers that we are looking at. Okay. Okay, what about independence? That's our ability to change the different layers without impacting the other layers. Right? So I could change the view that is to the external user without having to change the internal structure. Right? So we have mechanisms to allow us to do that. So we want independence because we don't want to have to change all 3 layers every time that we make a change. Oh, the languages, so data definition and manipulation. So what's definition about? Creating those schemas, creating the layouts, creating the views that we have associated with it. And manipulation is add, update, or delete the data in some way, right? We want to be able to, one is create the data, delete all of the data, and manipulate it in the other sense. Right. Okay, so we got a section on that. Okay, talking about embedding it and things like that. Oh, the utility. Oh, the data dictionary, right? So we spent time on the data dictionary. So what was important about the data dictionary? Right? It describes the data and how it's important to have your data described. Completely, but we don't do it. Why? Because we're lazy and it costs a lot of money. Right? So what do we end up with? People who are dedicated and not so lazy about it will create one for their segment, but it won't conform to the other layouts and stuff like that, right? So it's disjointed if you have it at all, right? Okay. Oh, the components. Oh, this is a great diagram. Oh, centralized versus decentralized. What would be an example of why I would want to centralize something? Centralize my data. Security, control, access, okay? Backup or recovery types of things. Okay? All the data is in one place. Okay. Well, what reason would I want it distributed? Speed, right? Because the larger I have, right? If I distribute it, I can distribute the data that is being used only to the places that actually need it. So it's going to be faster because I have less data to go through. Okay. So again, this goes back to that whole trade-off discussion that we had, right? So implementation processes around that. Oh, the clients, to server. Oh. Yeah, so we had the variations in. Right? So, hey, to your question, right? I mean, that's all I'm going to do is, right? What are the things we think about on all of these different slides? What are the things that we spend a lot of time on? As opposed to just saying, here's a slide. So in general, I'm going to go through and I'm going to pick out the things that we spend a lot of time on, And those are the kind of things that I'm gonna ask the questions on. Okay? So I haven't made it up yet, so I don't know what it's gonna look like. Okay? But, this is, okay. All right, so the ER diagrams, right, you guys already did those. We did the example of those, right? So, right, I should be able to ask you anything about those. You should be able to draw one, right? So, I would think that would, since we spent 2 chapters or 2 sets of slides on this, that would probably be one that's probably going to be a big one. If I was to just guess, right? Okay, so right, that's probably the only one that's not going to be short answer necessarily, right? So I will give you a scenario just like you did for the assignment, right? You're going to have to draw out, and how many different types of ERDs do we have? 2, right? So why do we have 2? Right? When are they created? Right? Okay. What's the purpose of that? Right? That's going to be the kinds of questions that we're going to have associated with those. Right? Okay. So given the scenario, what would they both versions look like? Or I pick one of them for you to do. Right? So, I'm not sure what else to tell you, sir. Right? Right? But again, I don't want you to memorize. That's not what I'm looking for you to do. Right? So, what I would do if I were you, like I said, I would go through the slides. What did we talk about? Right? Can I describe this in my own words? And if you can, just move on to the next one. I mean, that's pretty much how it was in the other class too, right? Right? So, and you did just fine there. Yeah. So. All right, so do you have any questions? Because certainly I want to make sure that I have covered anything that you want. Yes?
Wait, so today's lecture can be on the exam?
Absolutely. Wouldn't want you to think that we would not have it in there. Yeah,
It's open to all those notes.
you get nothing but what I hand out to you. Because the way I look at it is that if it's like open book, open note, that takes away all the easy questions I can ask you. So I'm not going to ask you something that you just copy off a slide then. That's not going to. So I think it's actually easier to have a closed book. And also students then don't really study. They just come in and wing it thinking that they're going to be able to just find everything, and it doesn't work very well. So. But it's easy. If you know it. All right, so if you do think of any questions, please send me an email, right? I'll be more than happy to try to make sure that we cover everything that you need. Yes?
Would it be reasonable to expect feedback on the ERDs that we submitted before the exam?
I am certainly going to try to do that. Unfortunately, I am going through a situation with a family member that is taking up a lot of time at this point. And I am actually dreading going home tonight because of what the news from the doctor will be on that. So, but instead of dealing with that 2 days a week, I'm now doing it every day. So I'm behind on all that stuff. But, all right, but again, right, is we went through, right? We did the ones in class. We walked through them in class. So, right, my feedback is not going to be much different than what we've already done. And not that I call anybody out in class, but even Kendra did the best in the class. Oh, did I say that out loud? Sorry. Didn't mean to do that. But, no, you guys did really well. Because I did get through some of them. I just haven't done them all. All right. Anything else? All right. So, relational data model and relational database constraints. Right? Now, I actually thought that you guys were like actually smarter than what you're showing me right now. Because if you kept talking, asking questions, I would never get to anything else to add to the exam. But you're too late now. Right? So you had your chance. Right? So let's go ahead and do this. All right? So a relational model of data is based on the concept of relations. Wow, is that shocking or what? Right? Okay. So the relational approach to data comes from the formal foundation provided by a theory of relations, which is ultimately why we have as the main approach now in the database world is using relational databases. Okay. Okay. So we're going to talk about some of the formal kinds of things related to this, but for the exam, I am not asking you to do any of that formal jazz, right? So, right, that's what references are for. But since you won't have any references, right, we just want to make sure that you understand that. Right? Okay, so in practice, there is a standard model that's based on the structured query language, right? So again, we have a set of relations. We have a language that we have, so a structured query language, and here's your test question, or what would be a great one, is what are the languages that are included in SQL? Hint, you've seen them on the screen already today. Yeah, data manipulation language and the data definition language, right? So within SQL, we have the two types of languages that are going to allow us to create, access, manipulate the data in a database, and ultimately destroy it if we need to. Right? So every database management system that is based off of relational types of processes is typically based off of SQL, because what's the first word in SQL? Structured, right? And what does structured mean? No, but it's a specific way or approach to do this, right? When you say you have a structure, you have a foundation that is always going to be there, right? So if, regardless of which relational type of data that you have, whether it's Oracle, SQL Server, Microsoft Access, DB2, right? Doesn't matter what relational system, SQL is basically going to work associated with that. Because the underlying structure that we have for relational systems is the same no matter which one. So what's the difference between the different types of database management systems that we just listed? The hardware it runs on, the operating system that it works on, the amount of data that you can access. It's got some different features, right? That's why we have different versions of programming languages, right? So I can have different versions of C++, because somebody didn't like the other one, so they created their own, which has the additional features, right? So that's what we look at and we think about, right? So, okay. And what is this bridging the gap between? The logical model and the physical model. Okay. So the key slide that you have to absolutely think about in terms of the exam is which one? The one that's got the missing things on it, right, that we've talked about probably 3 times so far. So if we talked about it 3 times, the likelihood it's going to be on there is pretty high, if I was to guess. Right? Right. All right, so a relation is a mathematical concept based on the idea of set. So it's basically set theory, right, when we think about it. Right? So it's been around forever, right? So, right, it was first proposed in 1970, which of course I'm never going to ask you to remember that day or that year, right? But the idea of this is that this has been around a really long time, right? So we went through, what's the first database management system type? Network. And why did we not want to do that? So see, this is the review as we go along. Right? Okay, so why did network fail as becoming the most popular one? It was complex, right? Everything was slow back then, right? But it was slow because it was complex. So complexity drove us, right? Because you didn't have a set hierarchy, you had this network, right? So each instance could have multiple parents, you didn't know which way it was going to go, your database management system's trying to manage all of this, and computers are already slow compared to what you have today, so if you had to deal with that, you would be throwing it out the window and stuff at this point, which we wouldn't want you to do. Right? So what came next?
Hierarchical models.
Hierarchical, and does hierarchical models still exist today? Yes. Right? Okay. What is the big advantage of something that's a hierarchy? That's the way that data exists in the real world, right? And what happens in the way that we group data in a hierarchy? We group it all together so that everything in the hierarchy is typically located in the same place in memory. So it is faster than your relational databases because of where we put the data. Right? So it's our physical location of the data is causing us in a relational system to be slower in nature, right, than the hierarchy models. Right? But the way that we lots of times think about data is in a relational way, so we have moved to relational because that's the way that we are thinking of the data from a modeling perspective. Okay. All right, so the good and the bad news about all of this is that we have formal and informal definitions. So the good news is that we use all of the informal definitions up to here, and then you, unfortunately, in here, get to tie them back to the formal definitions. Okay, so this relation is really what we refer to informally as a table. Right? Now, here's where it gets really complicated from the aspect of, if I ask a question, are you going to interpret my question correctly? Okay, okay. So we have this thing called a relation. And a relation is a set of, or a table of values where each row in a table is a instance. Right? So, what is that in relation to a database?
It depends.
Excellent. Excellent. Because it truly is, it depends. Right? So, if you talk to a number of people, when you talk about a table, it will represent to them, and they will refer to it as the database. So I have a student table, right? And when you talk to somebody who is not dealing with the database world, they will talk about it as the student database. Right? When I deal with parts, or I talk about vehicles, my business customer doesn't talk about the vehicle table or the part table. They talk about the part database and the vehicle database. Okay. In the database world, a collection of tables is considered to be the database. Oh, wait. My customer doesn't think about that way. They just say, I have a collection of databases that represent the business. Right? So what I'm trying to get across to you is that one of our biggest problems that we have from an IT perspective is the words that we say have different meanings depending on who is saying them. And there is no magic data dictionary that is going to describe that necessarily if you don't have one. So you, as you move throughout your company or you switch companies, understanding what the words mean, right? So we talked about this earlier. One of your first jobs, whenever you move within the company or you go to a different company, something like that, is you have to understand the terminology and what the terminology means. It's absolutely critical if you're going to get it right. And it's really hard because it will probably be different than what you have been used to. Right? Okay. Okay, so again, the relation typically contains sets of rows. That's great, but my business customer doesn't know a row of data means anything to them. They go, I have an instance of a part. They even say an instance. I have a part, and it's got some data associated with it. Not attributes, right? Characteristics, whatever words that you want to use, right? So, right, again, a key piece is understanding what the wording means behind the scenes. Okay? So, in front of me we have these relations. And that's because we are dealing with relational data, right? Okay, so we have these tables. So it's a set of data. Each instance is going to be an individual row. And what's a row? It's a logical grouping of data put together. So our part instance has a part number. It's got a part name. It has a part description. It has a part price. It has a supplier, right? I'm going to have all this different data, right? That could it all be separate? Yes, but we group them together logically because it makes sense to group them together logically. That's what our goal is. Okay, so this data element in each row represents what? Facts, right? That was our definition of what data is, right? So it represents facts, right? And it corresponds to a real world entity or relationship, right? And what do you know about this data? It is at a point in time, right? Because I can change what the name of the part is. I can change its description. I can change its price. But in the database, at any given point in time, I only have one set of values that it represents. Now, I may be able to go back with a concept called layering and see what it used to look like. Right? So on October 1st, 2018, the value of the description of this particular part changed from this to this. Okay? So we have databases that allow the layering or history processing so that we can go back in time and see what it looked like at a given point in time. But what does that do? That complicates things more because now I have to keep a history of anything that could possibly change in any data field at any point in time. So my database management system or my access to try to get that data is going to get more complicated in the process. Okay. So we call them rules or rows, right? But again, they have fancy names for them that you will find in textbooks. But like outside of that, I've never heard most of these terms. Right? We use the informal ones. Okay. So each column has a column header. Wow, that's pretty novel. That it's actually got a header or a name associated with it that describes the meaning. Ooh. Okay. So column header or attribute name, characteristic name, right? I mean, again, we have all kinds of it's known as, right? Different formats. Okay. So here's their example, right? So we have our definition here, right? So where is the definition of all this going to reside?
Metadata.
In the metadata, right? Because that's our catalog, right? Catalog, metadata, which one are you going to call it? Right? Actually, I should give you a nice test question that says, give me all the things that have multiple names. Ah, what a great idea. Why didn't I think about that?
Elpis.
So I give you I have multiple columns, and I just give you one of the column pieces of data, and then you fill in either the formal or the informal one. That'd be okay. Especially I give you the first letter.
Yeah.
Oh yeah, those are really great when I do that and you don't have a clue what it is and then you have to guess. I get some really good answers that way. Right? All right, so if we look at this, we have the relation name, right? So that's our, what's the other word for relation? Table. Okay. Okay. We have attributes. So what is the other name for attributes? Columns. Right? So we have names associated with those. Name, social security number, home phone, address, office phone, age, GPA. Oh, nice. Right? Okay. So each one of those is a individual attribute. It's also a characteristic. It's also a data field. It's a data element, right? We have all kind of different names just to represent a single piece of data. Okay, so what do we call the rows? Tuples. We also call them a record. We also call them an instance. Right? So there's lots of different names that have all of the same meaning. Okay? So if I was to draw this, what would you say? What's your starting point? I have a data field or an attribute. A grouping of those is going to create a row or a record of data. When I have a whole series of these records, what do I have? I have a table or a relation. What happens when I have a set of relations? I have a database. Right? Yes.
Does a relation hold between, say, name and home phone, or between Benjamin and Rohan? Is it between instances of different relations or between?
No, the relation is the entire set. Okay, now we had, right? So what is if we look at all of these particular students, what do we have? Start with a D. Domain, right? Right? In this case, how many students do we have? 5. Right? So if I look up to see if someone is a student, if it's one of these 5, they are a student, and if they are not located here, they are not a student. The domain is giving us the list of all possible valid values for that relation. Everybody okay with that? Right? So, give it back to me. So what is a domain? List of what?
All possible values.
All possible
What other way?
valid values, not just values, right? Because what it should represent exactly all the valid values. Right? So again, stepping back, right? What is your role in all of this? We have to have all of the data. It has to be the correct data. It has to be related correctly so that in every relationship, you know the domain, which is the list of all of the valid data that you have to work with. Your job is to ensure the integrity of all of that data. Because what happens if there's a problem? What if I know there are other students besides these 5? You can't trust the data, right? If I go to this relation and look up a student, well, they might or may not be there, but they still might be a student, but they might not, and I really don't know. So how do you deal with that from an application standpoint? You can't. Right? So again, our job when we go to design all of this is to ensure we are able to create and maintain all of the data in a way that we have integrity of the data and ultimately we have all of it. Does that make sense? All right, so we have keys to the relation. So each row has a value of a data item or set of data items that uniquely identifies it. It's called the key. Right. In this student table, Social Security is the key. Is that true? Go back and look. Social Security number unique? Up here? Name unique?
No.
Yes.
For this table, right? No, but that's my question. For the data that you know, is name unique? Yes. Is Social Security number unique? Yes. Is address unique? Yeah. Okay. What about age? No. GPA?
Yes.
Yeah. Right. All right. So, what was a candidate key? Oh, wow, this is great. It is something that potentially could make it unique. Right? So one of our jobs when we create our databases is we need to determine what would make it unique. Right? And what's a composite key? More than one field, right? So, right, you guys all kind of gave me the look when I said is name unique. Well, could I say is name and address in combination unique? Maybe, right? Okay, I can't tell you the number of problems that we have over time with juniors, seniors, right, in living at the same address, right? Because if you don't have the suffix on there, which one is it? Right? Okay. Now, what's the likelihood of name, address, and GPA being duplicated? Could happen, I guess. And it would happen on day one if you actually implemented it that way. Okay. So my point being is that, right, a lot of times it's pretty obvious what we want the key to be. But sometimes it's not. Sometimes we actually don't even have one. And we have to create one. Right? So, right? So again, having a key is really great, right, if they give it to you, but sometimes we have some type of ID, right? So it's called artificial key or surrogate key, system generated key, right? Something that is, right? So can you think of a key that you have on anything that you deal with that is system generated?
Student ID.
Hmm?
Student ID.
Yeah, student ID, right? Is that something that uniquely identifies you? Supposedly, right? Did you generate it? Is that generated off of your data?
Probably not.
Probably not. It might be, but we don't know. Okay. Okay. What about your account number? At any company that you're at, is that uniquely identified based off of your data? No, probably one that is generated by the system to say, okay, it could be just a one-up number from the last one that they did, but it's generated, right? If you had become a customer at that company 3 days later, you might get a completely different account number because they've already used the one that was assigned to you, right? Just because of the order that they do things, right? Things like that. Right? So a lot of times we actually use these different system generated types of keys. Yes?
Is it desirable for keys to have some meaning versus a system generated key? Is there an advantage to either or?
Okay, so let me, because I never answer questions directly, Mark, you know that, right? Okay, yeah, I can ask you a question, right? Okay, so what might be a disadvantage if I make something that is identified by you as a key?
Disadvantage if it's identified by me is what if I'm not accounting for future values in the database?
Well, no, I'm just saying for you personally, right? Okay, so what is a typical email address for you guys? Typically includes your name, right? Some form of your name, right? Do people sometimes change names? So if my key is made up of, it starts with the first 3 letters of your last name, and for whatever reason, your name changes and now it doesn't match, do I go back and change the key value? Because they typically don't go back and change it, but now the original, the data behind it associated with you has changed, which now causes that to not match.
Because if you change, the key value changes in the table, but it's referenced from someplace else.
Right. Or, you, in generating the number, you use the number of your zip code. Well, you've moved to a different location. Well, what one did you, right? So you have to keep track of all this extra stuff. So, in general, right, you don't want to tie it directly to anything that can possibly change. So, the answer to your question is, it depends. Right? If I am picking data that is about you, but it's not going to change, then it's okay. If there's a potential for it to change, even slightly, then it's probably a problem to do that. So,
Yeah, it makes sense.
okay. Did you hear that? What I said makes sense. Yeah. All right, so the formal definition, right? So the schema is a relation, so we denote it by an R followed by a bunch of A's, where R is the name of the relation and A's are all the attributes. So we have customer based off of customer ID, customer name, address, and phone number. Right? Okay, so we actually see this a lot. So this is something that you will see. And what you will typically find, right, so if we look down here, customer's name of relation, defined over 4 attributes, customer ID, customer name, address, and phone number. That this is where you will see, for example, the primary key or the thing that makes it unique will be underlined. Right, so I can look at this one thing, know what the relation is, what the attributes are, and which one is going to be the primary key associated with that. Okay. And in general, so not always, right, each attribute is going to have a domain or a set of valid values, right? So we could have, for example, that the domain of the customer ID is going to be a 6-digit number. And just given that, we know that it could be all zeros, so 6 zeros, or we could have all the way up to 6 nines. That is the set of possible valid values that we have. Right? What about a date field? You know, dates have a specific format, right? You're going to have a specific set of values for month, days, and what are valid years. You may have ranges, you may not. Right? Right? So our domains don't necessarily mean that it's values that you have. For a date, it could be anything that's a valid date in a given range as you go to put something into it. Right? So why is it important to understand what these domains are? To keep the integrity of this data, we have to edit to ensure that the data that we are, for example, putting into our table as an attribute have the valid set of data, because if it's not, we've lost the integrity of our data. Right? So we have our table or row, that's an ordered set of values, right? So each value is derived from the appropriate domain. So a row in the customer relation, right, is based off of 4, right? So 4 is the number of attributes. So 4 in a row would consist of the values. So in this case, we have the customer number, we have the name, we have the address, and we have the phone number. So listing them out like that. Okay. Right? So, for our domains, so our domains are going to have right, part of this is based off of layouts. So we can certainly have domains of the data that we have in a table. And now, right, so what's our two definitions for domains now? Right. Right, so it's for each attribute, I can have a domain, so does it match the layout and types of values that are valid within that single attribute? And what's the other one? For a given relation, the key will uniquely identify all of the possible valid values in the domain of that relation. So we have domain at the relation level, and we have domain at the attribute level. So if I ask you to define the different types of domains, you should give me two types, one based off of relation and one based off of attributes. So in our case, a domain has a logical definition for the United States phone numbers, it's 10-digit phone numbers, right? Okay, and right, we also have a format, right? So we have the area code in the parentheses, we have the dash after the exchange value, right? Okay, and it's all digits, right? Okay, and right, so again, a problem that we have is, right, is what about dates? Dates are just a big mess, right? So you have the US format for dates, you have European formats for dates. Do you use numbers? Do you use letters? Do you use abbreviations? Do you do full names? Right? I mean, it's just this big mess that we have to ultimately account for, and everybody likes to do it differently because it's what they are used to, or what data that they actually receive in, right? And a lot of times, you don't have a choice. Okay? So if I'm receiving data from a vendor, they aren't going to reformat their stuff to match what I have. I have to take what they already have in place, even if it matches mine or it does not. Right? So we have to, a lot of times, deal with that. Right? So, do we have dashes? Do we have periods? Right? Do we have Julian dates? Do we have regular dates? What's the way that we do it? It can go for it. Right? Okay. So, the attribute name designates the role played by the domain in their relation, right? So, a lot of times what companies will do is, in the attribute names, you'll say exactly what it is, that it is a date, or it is a phone number, it is a code, it is a status, right? And what happens a lot of times is different companies will say, all of our codes that we are going to generate are going to be 4-digit numbers. Statuses can be 2 characters in size, right? So they'll define that kind of stuff and say, right, so that you know when you create those that that's what's going to happen. Right? So I can look at different names that we have for the attributes, and I know what the domain of what it's going to ultimately look like. Okay. So our relation state is a subset of the Cartesian product of the domain. So each domain consists of all possible values it could take. Right? So we can do our cross product and come up with all the various combinations of things that you can come up with. Yeah. Right? So if our example here, we have a attribute called customer name defined over the domain of character strings of a maximum length of 25. So again, their definition is we have DOM representing its own domain. It's a domain of what? Inside the parentheses we have customer name, right? And what is the domain based off of? So varchar says is basically a variable length of characters, and in this case, we give the number, and it's the max size in this case. So max of 25, right? And it's going to be any character that we want. So it doesn't have to be A through Z. It can be a digit. It can be a punctuation mark. It doesn't matter, right? You can put anything you want in there. Okay. Okay. But ultimately, what you're saying is that it's a name of a particular customer. So we have domain based off of a data type, but we can also have other constraints. It has to be alphabetic. It can't contain spaces, right? I mean, you can put in any type of constraints that you want. Right? So formally, so given our relation and all of its attributes, right, we can come up with a specific state or value, right, population that they talk about of that relation, which shows us the row, right? So a row is going to be based off of, it's going to contain something from the domain of A1 plus something, right, crossed with the domain of something in 2, right? So again, this is just a formal way of saying take any of the Cartesian product or come up with any of the combinations and it's going to be valid. Okay. So I'm not asking you to be able to recite this page, right? But what I want you to be able to state to me is what are the values in the rows? The rows are going to be made up of something that is going to come out of the domain of each of the possible attributes. That's all we're looking for. Right? So this is a really formal way to state that, right? But the idea is that right, we can formally describe it, but I want you to just be able to recite what it really is. Okay?
State on the previous page was used in the same context as state earlier, right? Just a formal definition. So it's just saying a snapshot of time.
Point in time. Right? Because all of the attributes that you're going to have in any row is your state. So at a given point in time, here's the values you have in those particular attributes, and that's the current state or the current behavior that is in place. Okay? Right. So if we were to look at this, right, so this is a, I just like that the textbooks give you these really nice examples, right? So domain of A1 is 0 and 1, and the domain of A2 is A, B, and C, right? So therefore I'm going to have a grand total of 6 different combinations that I can possibly come up with. Well, that's really nice, but let's pick a attribute that is a date. I've got 365 days in a year. And I'm going to keep track for 50, right? I mean, to write out all the different combinations, right? You're just not going to do that. Right? So again, the key thing that I am looking for you to be able to state is that each attribute is going to have a domain set of what's valid based on the data type and any constraints that you have associated with it. Right? So what if I was to say I have a field that represents a state of the United States? The abbreviation for it. So what is going to be the format for that? If I look at the format for a state. How many characters? 2. How many values?
Right now?
Yeah, right now. How many?
50.
Because I'm sure that you thought of PR for Puerto Rico, for example,
That's not a state, though.
but it's considered, it's in the list. If you were to look for address is and what goes into the state field, a valid address considered to be a United States address would consider Puerto Rico.
And Guam.
And okay, GU for Guam. MH would be the Marshall Islands. So it's not 50, it's more than that. But what is your constraint? Does it have to be an actual United States state? Is it a valid postal address? Right? My point is that what do we know about that data field? We know that it's definitely for sure 2 characters in size. Now, what is your constraint on what the data values are? It has to be in the continental United States. I only get 48. It has to be an actual state of the United States. I have 50. It's any postal address available through the United States Postal Service definition of what can go into the state field. More than 53, right? So what, again, if you are going to maintain the integrity of this data, what are you checking for? So why, in a lot of the web pages that you deal with, do we have pull-down lists?
Easy for the user.
It's what?
It's simple, it's easy for the user.
Oh, absolutely not. That's a true fact, but we don't do it for that reason. Okay. We do it because if you can only pick what's in that pick list, you know that piece of data is always going to be correct. The fact that it's easy for the customer, that's secondary. We are trying to maintain the integrity of the data, and if they can only pick valid things, because I know the exact domain, we win. And actually, sometimes when you have these really long lists, it actually takes longer than if I could just type it in. So it's not so easy. Right. So, like the way you're thinking, but close. Right. All right. So we have different scenarios in this. So again, right, what I want out of this is, you know, that we have data, size, and format, and then any constraints on the actual data values itself. Right? All right, so if I look at our informal versus formal terms, we have table versus relation, column header versus attribute, possible column values versus domain, row versus double, table definition versus schema, populated versus the state, right? So again, right? I don't think that I have heard any of the things in the formal terms in real life in probably 15, 20 years. We all talk about the informal things. Right? So I want you to be able to talk about it in terms of the informal things. But of course, all the textbooks have to talk about it in terms of the formal things. Right. So again, they just gave us the example back again of that to show us. Okay, so what does this wonderful lines in here called null mean for an attribute?
So there's a valid non-value, so it's, to not have a value is a valid part of the domain.
Yeah, we just don't know. It's got a value, but we don't know. And it could be unknown. But we do not have a value, so we can't report what that value is. Okay? Now, Cooper, what's 2 favorite words in IT?
It depends.
It depends. So, a lot of database management systems will use null, but there is a set of them that will use nil, N-I-L, instead. just to mess with you. Okay, so null has, as we said, it represents that there is a value, we just don't know what it is. It doesn't have a value, but we don't have a specific thing that represents no value, other than null. Okay. Now, what can you tell me about any line in here, or any row that has a null in it, in terms of those attributes? So in this case, home phone and office phone. What can you tell me about those? Yeah, we can't use them as a key because there's these ones that we don't have a value for. And a null is the same as another null. So it's not unique anymore, so we can't use it as a key. Okay, so characteristics of relations, right? So, right, even though, right? So again, I like the way the book kind of puts these things, right? So the rows aren't considered to be ordered even though they show up in this nice table. Right? What is that really saying? What that's really saying is that behind the scenes in our actual database, we don't necessarily have them in any kind of order. We can, using our SQL, we can put them in different orders, but the way that it's returned from a request doesn't necessarily have to be the order that it actually physically appears. So when they say the tuples or the rows are not considered to be ordered, we want to make sure that you understand that it's because physically, behind the scenes, we can have differences in the way that the data is actually physically returned to you and when you make a request versus how it is physically stored out on the storage location. Okay. We also tend to order them the exact same way in general, right? So we will always consider something to be attribute 1, attribute 2, all the way through, because we have to have some order that we're putting them into where? The metadata or the catalog. So we list them, but it doesn't have to be the way that it physically stores them. Okay. What would be an example of where I don't necessarily physically want to store it in the exact same way that it's defined in the declaration or the data definition language? What do I want at the, if I have 5 fields and one of those can change size, do I want the one changing size in the middle someplace? Probably not. I want to keep that one at the end, or I need to put that in some other location, right? So behind the scenes, the database management system will make a determination of what is the best way to store it, which isn't necessarily going to match exactly the way that you are describing it, right? So there's those kinds of things that are going to happen. Okay. So it appears that they are in order, right? Okay, but they aren't necessarily. And what about the thing at the bottom? What is that kind of looking like? Even though they call it self-describing, what do we really call it in real life? Name value pairs, right? So we have name and it's John. So security number 1 through 9, right? So we have a piece of data, we have the name of the data followed by the data value itself. So in our instance here, what do we know? We just kind of reordered some of the things, right? So again, you don't know how it's physically stored in the database. It could be returned in different things. So that's why typically when we make requests out for the data, we tell it the order that we want to actually get it back. Because there is not a guarantee that you will always get it back in the exact same sequence. Okay. And why would that be, for example? Right? Even when we say, I want it ordered by something.
New data.
Okay. Okay. What do you know about your different computer systems? They all can have different ways to represent numbers and letters and stuff like that. Okay. So I have one database management system that when I say I want it listed in ascending order, we'll put things, if I take a field that's a mix of letters and numbers, it will put the numbers first. If I take the exact same database, I have it on a different piece of hardware with a different operating system, and I say sort it into ascending order, the numbers will be last. Same data, same request, put it into ascending order, I get two different sequences. I get all the same data, it's just ordered completely different. So that's what we're trying to say here, is that there's other things than just the database management system that are coming into a play in where the data is, how it resides, and how we access it. Okay. All right, so the values that we have are considered atomic, meaning we can't divide them up, right? So they're indivisible. Okay. And as we said, each value is from a domain of values that we have for each of the attributes. Okay. And as we said, we have this special null or nil, as the case may be. There is values that are unknown, not available, or inapplicable in that specific row or instance. Okay. So again, the book kind of puts it in their notation, right? So we refer to the component values by having the values for a particular attribute, right? Or we use the dot operator. So that is the particular value of that attribute for that particular row. So really nice, but don't memorize it. Okay. All right. So we talked about some constraints, right? So constraints determine which values are permissible and which are not. So the three main types that we are going to deal with. So, Mark, let me ask a question. Does this sound like a really great test question?
Sounds like a great test.
And would you just list the three types?
No, you would provide a description in your own.
You would probably have to describe them. Right? So again, if I say list something, what do I want? I want a list. If I say describe it, right? I can't tell you the number of times people don't do what I have asked. And it's really great if you give me a description when I said list it. I don't even read it. I don't care whether it's right or wrong, right? Is the list of things correct or not? If I describe it and you don't describe it, you're never going to get full credit. Right? So read the words of what I ask, right? So the three main types are inherent or implicit constraints. So based on the data model itself, right? Okay? So our relational model doesn't allow a list as a value for any particular attribute. So again, we are implicitly or inherently putting some constraint on it. It has to fit into exactly the format that we are asking for. What if it's a date field? You can't put in a character string, right? So it's implied or inherent constraints that we have based on what we're looking for. Okay. 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 Okay, so our schema-based or explicit constraints, so expressed in the schema by the facilities provided by the model, right? So again, what do we have in our ER model? We had one-to-one, one-to-many, many-to-many, right? Those are constraints, right? 0, 1 or more, 1 to 5, right? We can put that in when we create things, and a lot of times the database management system will automatically apply those. Okay? And then the third one is the application-based or semantic constraints. Semantic is really about meanings, right? Okay, so these are beyond the power of the model and are specified and enforced by the applications themselves. Right? Okay, so right, this is where you have what kind of things when you have a web page and you're entering stuff. You have required fields. Right? You have formats that are going to be applied for the way that the data is going to be entered, right? Whatever that is, right? That's not the database management system, right? But the result of what goes into the database is going to be based off of the application edits that you have. Right. Okay. So we have the inherent or implied ones. We have the schema-based or explicit constraints that we're putting in when we create the schema, and then we have the ones that aren't in the schema itself but are applied outside. Okay? Any question on that?
So application one, that would be like a range of dates, so it's, the inherent constraint would say that it is a date,
Yes.
but the application one would say that the date is within this range.
Yes. Yep. Right. So you're not relying on the database management system to put that constraint in place. You are applying it as an application. Right? Any other questions on that one? Okay. So our constraints are conditions that must hold for all valid relation states, right? So in the example that Mark gave us, right, we're checking this piece of this date, and it's got to be in the valid range. If it's in the valid range, we are going to apply it. If it's not in the valid range, we reject it until we get one that is valid. Okay. All right, so within the explicit ones, we have 3, right? So now we have implicit, explicit, and application bound. And then within the explicit, we have 3 other ones. I can see a great question coming out of this one. Okay, so we have key constraints, entity integrity constraints, and referential integrity constraints. Okay. So we'll talk about those in a little bit, right? So another schema-based constraint is the domain constraint, right? So it has to be from the domain of its attributes. So again, this kind of gets back to the idea of, right, we can force it to be, right, in the, so this one is a it depends scenario. So there are some database management systems that will allow this, other ones that you have to do it outside of this. So. Okay. So, for example, we could have instances where you don't allow a null, for example. So you have to put in a value. What thing do you have to always have a value for? Your key values, right? So that's a constraint that we put on that it can't be unknown, right? You have to provide that. All right, so key constraints, right? So this one is pretty murky, right? So a super key of the relation, it's a set of attributes, is the super key of the relation if the following condition, right? No 2 of the rows in a valid relation state will have the same key. Well, it sounds like it just say primary key, right? Okay. So why not just say that, but they don't say that. Right? So they say, oh, so they can't have the same value for multiple rows, right? For any distinct rows, right? the super keys can't equal each other, and this must hold across everything. So it's really nice, but all I want you to know is if you have a primary key, it's going to be unique, right? So we know that. Now, right? So super key is the equivalent in here of primary key, but a key, right, is a minimal super key. That is, a key is a super key K, such that the removal of any attribute from that results in a set of attributes that's not the primary key or the super key, right? Okay. So don't get hung up on this, right? We talk about this because it's in the book. I want you to know that we have key values. What are the keys that I am concerned about for you? We have a primary key. A primary key is something that you select from a list of candidate keys, which could include composite keys, that is going to make each row in the relation unique. That's all we're really trying to look at here, right? When they talk about this minimal super key and all this kind of stuff, right, they're talking about the composite keys, pulling pieces out of the keys, right? I don't think they did a really good job of explaining this, and I don't think you really need to be able to recite that back to me. So don't try and memorize this or even try to put it in your own words, right? So again, I want you to be able to tell me candidate key, composite key, primary key. Right? Those are the ones that I want you to be able to respond with. Right? So if we look at some examples of this, right? So we have the car relation, and car had state, its registration number, its VIN or serial number, make, model, and year. And we talked about in the examples that there was 2 keys associated with this. We had the state and the license associated with it, or registration number. And our key 2 was a serial number. Right? Okay. So both are super keys because they both uniquely identify, right? So what do we call those? Well, which one is composite? Key 1 is composite, but key 1 and key 2 are candidate keys. Because how many primary keys are you going to have? 1. Right? Okay. So they're both super keys because they are both candidate primary keys. Okay? Okay, so serial number and make. What about that? Is serial number and make unique? Say yes.
Yes.
Why? Because serial number by itself is unique. So adding anything else to it is still going to be unique, but right, this isn't helping us any. Right? Okay. So if we have this extra stuff and we can take away make out of this and still get the super key, right? Okay. We don't call it a key. Right? So again, don't get. So any key is a super key, but not vice versa. Right? Any set of attributes that includes a key is a super key, and a minimal super key. So very nice. Right? I wanted to try and walk through it because it doesn't make a whole lot of sense. You are never going to have to deal with this outside of here. Right? It's really nice for a formal definition, but what keys are you going to be able to describe for me? Composite, candidate, and primary. With more to come. That's great. Okay. All right, so if a relation has several candidate keys, one is chosen arbitrarily to be the primary key. Oh, wait. How arbitrary is it?
Hopefully not.
Oh, we can be. So consider the car relation where we had the state the registration number, the serial number, the make, model, and year. We would choose serial number. Why would we choose it? Uniquely identified. Oh wait, so did state and a registration number. Okay. So you want to pick single key values if you can. So the fact that serial number is a standalone attribute, primary key, you want to pick it. Right? Now, it talks about here, choose as the primary key the smallest of the candidate keys in terms of size. Typically, yes, if you are comparing after you've narrowed it down and taken out all of the composite keys that you can. Right? So, they're not very specific on that, right? So, your first thing is that if I'm able to have non-composite primary keys, those are then get as a subset of the candidate keys. That's the ones I'm going to look at. Once I get that down, then I apply this size rule. Okay. So the choice is sometimes subjective. What do we mean by that? Okay, think back to what we talked about earlier. Language of a company. Right? A lot of times what you're going to have is from a database perspective, you're going to get requests that are going to say, I need this data or this information to come out of the database. And somebody who doesn't understand how the database is structured, right? They're thinking, right, whatever they're thinking the primary key is, this is what I'm going to be able to provide to you. That might not have been the best choice because it's not the smallest, but it makes sense because of the request that you're going to be getting. The end result is that you want to do it so that it makes it easiest for you, for the application efficiency, things like that, right? So as we said earlier, there's all these trade-offs that we can have, right? And your job, if you are evaluating these, is to determine what trade-offs make the most sense. Right? So in here we have a different relation now, so it's really great that they like changed it on us. Right? So the book changed it now to it be license number. We have an engine serial number. So in the other one we had other stuff. Right? So they combine the state and the license plate number all into one field. Does that make sense to you?
No.
Thank you. Right? So, Mark, do I ever accept an answer of just yes or no? No. So, you would always answer Cooper as to why you think the answer is no.
Oh, that's non-rhetorical. I think.
Or you could ask someone else if you would like to have them answer since you were correct.
I think that there are two atomic data points inside that one field.
Yeah, right? Absolutely, right? So we said that we shouldn't be able to divide up any, right? They should be atomic, right? Indivisible, right? Well, this is clearly divisible because we have the state and the license plate number, right? Now, they are certainly related, right? But two pieces of data that you mash together into one that ultimately someone is going to want separated. All right, so from our schema perspective, right? So our relational database schema, we have a set of relational schemas that belong to the same database. So this gets us back to the database being made up of multiple relations. But your customer is likely to think of each table as its own database. Right, so understand the wording. So S is the name of the whole database schema. So as we said here, right, and we have the set of relations. So S is equal to the whole set of relations. And we have, they have the cool IC for integrity constraints. And so what do I need to do that? Okay. Where R1, R2, all the way through Rn are the individual schemas that we have that represent the individual tables. Okay, so what would you be able to, if I gave you something like this, what would you be able to tell me? The company database is made up of how many tables? 6 tables, right? And the employee is going to be, have how many attributes? 10. And the primary key is? Social security number. What about department? Has how many?
5.
5. And try it on the exam and see how well you. I'll laugh.
Yeah, me too.
Yeah, I'm sure you will when you get it back. All right, so the department has 4 and it has a department number. Okay, what can you tell me about department locations? It's a composite key made up of number and location. That'll sound like a really good one.
Maybe.
Maybe. Okay, so let me ask this question, is if I have a department number, can I get information about the department?
Yes.
Right? So I could go from the department number to the department instance and get who the manager is, right? And the department name. Can I get anything about a location anywhere? Outside of the fact that it's in a department, do I have any information about a location anywhere? Okay, so here's my question, what I'm trying to get to, right? What do we know about the department that appears in department locations? What's the values of that? Right? The valid D number in department locations needs to come from the domain of department. Has to. If I'm going to maintain the integrity of my data, right? Because what happens if I have in department locations a D number that doesn't exist in department? The data's wrong, right? So now you're saying, I got this thing called location, but how do I know it's a valid location? Is there something that I should be tying together? Maybe, maybe not, right? But again, what I'm trying to get to is, you need to ask questions about this. You may not have something like that that I can go against, but that is leaving me open to have a invalid set of data from an integrity standpoint. Okay. Okay, what about, works on down there? We have ESSN for employee social security number.
It's a different, it's got a different name than the SSN and the employee table.
Does that sound like a really great idea to have two names for exactly the same thing? No. And if I am going to have the integrity of my data, the ESSN should come from where? Right, employee. Right. Okay. Now, what about this pro thing down here, or P&O?
Is that supposed to be the project number?
That's what I'm assuming that it is. Does that sound like a really good description since we're guessing at what it means?
Is there an O number?
You could.
This is strange.
We have NO being, NO period being number. NBR can be a number. So, yeah, kind of.
Kind of.
It, looking at it, I would not know what that means. So again, what is it we're trying to get across to you for in this part of the conversation? When you're going to describe something, it should be obvious what it is that you are creating. Because if it's not, how are you going to know how to deal with it? Okay, so we have a database made up of 6 tables. Each one has a primary key that is either an individual or a composite. We should be able to tie some of these things together to keep our integrity of our data. Okay.
I have a question. To me, it looks like works on might sort of be defined as a relation that holds between an instance of an employee and an instance of a project, and they've hung this attribute hours off of it.
Mhm.
Is it a relation between relations? I know that sounds crazy, but with ERDs, that language is used to describe.
Oh man, what a great idea, Cooper. I love it when you help me out like this. All right. So what would the ERD look like for this? Since this is built, we should be able to have a built ERD associated with it.
Well, for that specific entity, one would assume that it's probably a diamond with an attribute hours.
Between?
If that's how they've designed it, I wouldn't design it that way, but.
No, but we have employee is related to a project, right? And an employee can work on multiple projects, and a project can have multiple employees. If I have a many-to-many relationship, I can hang a attribute off of that because the hours in this case is not associated with the employee and is not related to the project. It's related to the combination of that particular employee on that particular project. So it has to be off of that. Okay? Okay. And we have a relationship between employee and dependent. Right? And what type of relationship would that be, cardinality-wise? One employee can have multiple dependents because our dependent, the primary key is dependent name, and if I'm going to create it physically, I have to put the 1 on the many side. So the employee number is going to be on the dependent side, because there's no relationship that we're using it, or this is how we're building it. Okay, so we have employee and project. We have employee and dependent. Okay, and now we have a department and this department location thing. So that could mean that we have a locations entity, and we're not actually building that, we're associating it somehow, right? But I wouldn't build it this way either. But the point being is that I should be able to, if I give you a build ERD, you should be able to create something like this, or given something like this, create a ERD working backwards from it.
So my question really is, it seems like there are two different definitions of relation, one that holds between different entities, and then the definition of relation that is the set of attributes for an instance of a
Yes, it's really cool, yes. You are absolutely correct.
That's a no. They should have two different words.
We have given you a whole sequence of them today that are words that have multiple meanings.
I'll just see what they want to make.
But the good news for you, and the bad news for me, is that if I ask for something specific and you answer it in a different way, because you've interpreted it to be the other relation, as long as I can make sense out of it with your answer, I'd give you credit even though it's not the one I asked for. Because otherwise you would have come and asked me, but you didn't, because you know which one immediately popped into your head. So, but that means I have to go, does it really make sense? How would Cooper come up with that as the thing? Stare at it for like a half hour or something and then come up with it. All right, so everybody see how we went back and forth between these? All right, so again, I should be able to give you this and say, tell me what this means. I should be able to say, here's an ERD, derive the database from that, because it's the build ERD. I should be able to say, given this, what would be the build ERD that is associated with this? Right, and again, you just work from your keys and so everybody okay with that? Because what's the answer if you don't ask? You understand. All right, so the database state, right? So the relational database state is the database of that set of relations that we had, right? So again, what are they just trying to say? They're really making this hard. All they have to say is the database state is the set of data that you have in all of the tables or relations at a given point in time. Because at every given point in time, all of the attributes can only contain one piece of data. So they go through all of this and they make it really hard. Right? That's all you have to say. I have a state of a given attribute. I have a state of a given row. I have a state of a given relation. I have a state of the entire database. And it all can be at the exact same point in time because each one of those is a subset of the other. So they got all this wording here that really makes it really hard. Okay. So again, we're really talking about this idea that it's a snapshot or a instance or a point in time that we are dealing with. Okay. 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 So they say don't use the term instance. Why? Because it has multiple meanings. Oh wait, relation has multiple meanings. Table has multiple, database, you can apply that to everything. Right? Okay. Okay, the database state that does not meet the constraints is an invalid state. Wow, that's a pretty awesome statement. If I have a constraint and you violate it, therefore it's invalid. Okay. I'm trying to figure out how many pages they put into the book that are actually like fluff just to make it bigger. Okay. Right. All right, so each relation can have multiple tuples or multiple rows in its current state. Well, that's a big deal there too, right? And the relational database state is the union of all the individual relations. Wow, this is just so profound thinking. Whenever the database is changed, a new state happens. Okay, so the thing that we can talk about here that is a little bit different is what are the operations for changing the database? And we have 3 of those. Right? We can insert a new row. We can delete an existing row. Right? Or we can modify a piece of data in it. Right? So it's add, delete, change. Wow. Right? This is profound stuff. Right? Okay. Right? So, right? Now, what they don't talk about, which they should, so instead of doing all this kind of stuff here, right, we can also do what? We can create a whole new table. We can delete an existing table, right? Or we can modify an existing table, so I can add a column, I can delete a column, right? So they talk about changing the data, but we can, my point is that we can also change the whole structure by adding new instances. Okay. Right, so they've just kind of given an example here of all the different populations of the data. All right, so we've talked about integrity a little bit, so let's talk about it a little more, right? In a little bit more detail, right? So entity integrity, right? So the primary key of each relation can't have null values. So we're going to talk about that, right? Because if I have one null, I can potentially have another one, right? So no nulls in primary key field. So we can add that as a constraint when we create the database or the table. Or there are some database management systems that will automatically apply that when you say it's the primary key because it's, right, it's inherited in that. Okay, so that's because the primary key is used to uniquely identify each of the rows that we have, right? Okay, so it can't equal null, right? And if it's has several attributes, and what's that mean? What kind of key is it? Composite. So, right, the primary key is always a candidate key, and it may or may not be a composite key. Okay. So, if it is a composite key, null is not allowed in any of the individual fields that make it up. Okay. So, They just want to note on here that other data fields that you can say that those are required to have a value. Right? So an example may be you have to have a address field that has to be filled out, but it's not part of the primary key, so it can't be null. Right? So as a constraint, this is allowing us to say you have to have a piece of data in that field. Okay, so referential integrity is the idea of we have a constraint that is involving two relations. Okay. So our previous one would only involve a single one, right? It was in an attribute in that field is required to have a value or not, and primary keys have to have values. Yes, Cooper.
What is the primary difference between a key constraint and an entity integrity constraint?
All right, so we'll get that if we go through these, okay? Right. So when I forget to answer that, you ask it again, right? All right, so we already talked about a referential integrity, right? So this is looking between two relations. So what did we have in our last example back here that was referential integrity? The D number field in department location had to exist in department. Right? If I try to put something into department location that has a invalid department number because it doesn't exist in the department table, the database management system, because we're doing referential integrity, will not allow it to be entered. Now, this has a really great name associated with it. It's called a foreign key. So a foreign key is a key that is a primary key in some other relation. So what are all of the foreign keys that we have in this layout? Right, so D number, ESSN, both of them, both instances, right? Okay. What else? Yeah, that whole PNO, which is Mark really loves as a number. There, right? So that's a foreign key, right?
Is super SSN a foreign key?
Is which one?
So in an employee, there's the supervisor's social security number.
Yes. Okay, so everybody see what Cooper said? Right? Okay. Is in our example over here, right? It's easy to see that this D number in department locations is associated with this one, right? With department. So I know that that is a foreign key. The employee social security number in both of these is the same as the one in employee. So that makes sense, right? Our project number is associated with the project number here. Again, what do you want to do when you name them? They should be named the same. Right? Okay, but what Cooper is pointing out to us, very appropriately, so thank you, Cooper, right, is the supervisor's social security number is associated with employee, right? So I have what kind of relationship is that? Unary, right, or recursive, because it goes back to itself, right? Now in this one, I have to have it named differently because I can't have two attributes named the exact same thing on the same relation. So I have to have it different, right? So if it's a straight foreign key only by itself, like it was for works on and dependent down here, all of those should be SSN or ESSN, right? They should all have the same name. But because SSN and super SSN are on the same relation, I can't have two attributes on the same relation with the same names. So we have to name one differently, and obviously it would be the supervisor SSN. Right. So now we have composite key, candidate key, primary key, and foreign key. Excellent, right? So typically, when we write these up, right? So in our example way back when we had customer and then we had the 4 attributes, right? You put a full underline under the primary key, whether it's a single or multi-valued, right? So composite or not. Foreign keys would have a dashed line underneath. Because we want to know that, because it's not a primary key, but I want to know that this is a key in another table because I want to make sure that if I'm going to create it, that I know that that's the referential integrity that needs to ultimately be created. Okay. Okay, so as we said, right, the primary key one is what? It's the domain of all the valid values that you can have, right? So in our example that we had for department, where department number was the primary key, that's all the possible valid values for a department. You don't have a choice. If it's not there, the department doesn't exist. Right? So as a foreign key, our referential integrity is going back and looking at the domain of valid values and say, does it exist or not? And if it doesn't exist, it will not allow you to update it to that value. So the database management system is doing that behind the scenes. That's all they're trying to say there, right? Is right? In the row, the foreign key is going to equal the primary key in the other location. Right? So as we said, we're just going to look through, right? Now, foreign keys can be either a value. If the value exists, it has to reside in the domain. But a foreign key can also have a value of null. So primary key, it had to have a value, and it had to be unique. A foreign key has the possibility of being null. That means that there just isn't a hookup in that relationship. But you can also make it so that the foreign key field is not nullable, so you can force it to have one. So again, you have to understand the constraints that your customer is putting on the data that you have and how it's being used. So you have to know that before you can, obviously, build it. Okay. All right, so Cooper had his question way back here someplace. Right.
One more. Yeah, so, no, just kidding. next slide, I believe. Yeah, so key constraints and entity integrity constraints seem like they have very, very similar formal definitions.
Of course they do.
What differentiates them?
All right, so what's the idea of these key constraints? So let's start with that one.
That there's-
That's my primary key, can't have any null values, right? Right, if it's made up, it's a composite primary key, none of the individual fields can, right? So it's that kind of scenario, right? Okay, so that's around just the creation of what the primary key is. Okay. So what would be, what's the idea of an entity? It's the thing, right? In our case, department, right? So what they're talking, so we've kind of talked about this, but we didn't call it this, Cooper, right? So the key constraint was if I'm creating this primary key, can't have the null values anywhere. The entity integrity constraint is within the department relation itself, it has to contain all of the departments. Right? So what do we say the domain was at the relation level or the table level? It has to contain every single one of the valid entries. If it's a department, it needs to be in the department relation. If it's an employee, it has to be in the employee table. Right? So this is making sure that you have in the relation itself all of the correct data in the original one. Right? And then what's the referential integrity? Using a foreign key to check against that data to see if it exists or not. Does that make sense?
Is it an oversimplification to say that the key constraints are the constraints that exist on any key attribute and then entity?
If you are going to select a key, it has to be unique, it can't be null, right? If it's a composite key, none of the components can be null, right? So the key one is really around what are the rules that we talked about selecting what will become a primary key out of all of the possible candidate keys, right? So given a list of candidate keys, you may look and say, oh, this one is composite and this field can be null, so this is no longer a candidate key. Right? These are, right, I have a single value, right? I have 3 candidate keys that are single value and 4 additional ones that are composite. I want single, right? So you're working your way down, right? And then you go, what is the most common one that the customer is going to reference, or if they reference all of them, what is the size? Okay. So it's the key one is how do you go about selecting the primary key that you're going to use? Okay. The entity one is given this department or this employee, how do you ensure that every department is listed in it? How do I know every employee is listed in it? Right, so how am I building the entity itself, the domain of values for the entity? And then referential is given the fact that I have foreign keys, making sure that I can use the primary key that's got all of the valid values using the primary key I selected in the first one to maintain the integrity. So they are in the order that you process those. So Cooper, did I answer your question?
Yes. Because, yes.
And I think it's a great test question, so I hope that all of you understand it as well. All right, so displaying our relational schema and its constraints, right? So what do we know about all of these wonderful schema things? Where are they located? In the catalog or the metadata, right? Okay. So our relational schema can be displayed as a row of attribute names, right? The name of the relation is written above the attributes, primary keys, underlined, foreign keys. Right? They have it as an arc, right? I have never seen it written as a true arc, right? I've always seen it as a dashed underline. Okay. Okay. So when we go and look at this, right? This is really nice. It's a great example. I have never seen one like this. Okay? And the reason for this is, right, for me as example, I have not 6 of these, I have over 550. I can't draw something like this and have it work. Right? So, it's really great that these wonderful arcs as they have, basically back to Cooper's, the super SSN is drawn over to SSN, right? It's showing that it's a foreign key, right? Okay. The DNO out here is also one now that we look at this, right? Okay. Okay. The ESSN, the PNO, right? So you can look at this and see all the different ones, right? So again, the point I want you to see out of this is that if I ask you to describe this, these are all the foreign keys that you should be pulling out of this. Right? Now, why is it hard on this one? Because they keep changing the names. They are not hard if everybody keeps the names consistent, except where they absolutely have to, like in the Super SSN, because it's a unary relationship. So drawing it like this is great if it's something nice and small. If you decide that you want to do that on an exam or something, that's okay. But I just want to let you know that you will not see something like this in the real world because we just can't fit it on a page like this. It's just not going to work. Okay, all right, so other types of constraints that we have semantic integrity ones, right? So based on the semantics or meaning, right? Semantics is really about meaning, right? And we can't express them by the model. So the maximum number of hours per employee for all projects he or she works on is 56 hours per week. We're not going to have that as part of the database management system, right? So we're going to have to put that in the application around it. Right? Okay. We have to we have constraint specification language that companies will use. So, right, for us as me as a database administrator in one of my jobs and in my current job when I interface with the data administrators and database administrators, we have a specific language where we state what these are. So again, everybody's on the same page from a communication perspective. Okay. We have the concept of the things called create, trigger, and create assertion to express some of these. So this is within the SQL itself, right? So again, depending on which version that you have. So when we talk about SQL in the next lecture, as opposed to the exam next time. Right? So we have keys, we have use of null values, we have candidate keys, foreign keys, we have referential integrity, right? We could all set that up in the create table scenario, right? So what are these creates? Which language is that associated with? So- Right, the definition language. We're not manipulating it. We are creating things. So the definition language. Okay. So as we said, we can insert or add, delete, or modify. And again, they talk about it in terms of a single row, but we talked about it if we're doing it at the relation level. It's going to be instead of a DML statement, it's going to be a DDL. Right? Okay, we have integrity constraints can't be violated, otherwise it's going to be rejected. Right? You can update different operations together, right? And we can propagate things together. Okay. As I said, in case of our integrity violations, right, it can cancel it, right? So we have a restrict or reject. We can actually perform it, which is not a really wise move since you have an integrity problem then, right? We can trigger additional updates, so we'll talk about this when we action it. So cascade is do another action beyond what we're doing, and set null is I got a problem, so we know null. As long as it's a nullable field, we can set it, meaning it's unknown at this point. So come back and fix it later. Okay. All right, so our violations, right? So it's just the idea of the different problems that we can have. And so we've talked about most of these already. Right? Okay. From a delete, right? So what would be a problem with a delete? If I delete a department and it's in the relationship as a foreign key, right? So again, I can't do that, right? So there's issues associated with that, right? So we'll see these again later on, right? So point being is that we have issues, we can deal with those. So the exam, next time, make sure that you email me with any questions that you have. I've given you a relatively big sample by asking you all these questions in class, right? Those are the exact types of questions that I'm going to ask, right? Practice writing if you need to, right? Hand will hurt, right? Mark always gets mad at me at the end of each one of them. So. All right, have a great week.
You too.
Thank you.